You can see here the different years. In 1980 it was really very expensive. This is, the unit is euro per watt peak. And we had here something like, it's maybe 30 euros, something like that. And now it came down to less than 1. So the price development, the cost development in the PV, in the case of PV, is really astonishing. Okay, so maybe one slide more. Here we can see the levelized electricity costs 2013. Levelized electricity cost means let's say the average electricity costs over the lifetime of a system. This is called in the terminology, specialized terminology, levelized electricity cost. This is quite new from 2013, and you can see that again that especially wind energy now is quite cheap, comparable to the costs of the electricity generated by gas power plants, combined gas and steam power plants, coal power plants. So this is wind onshore, and here wind offshore on the sea. This is much more expensive than onshore because of the logistic problems you have constructing wind turbines on the sea, and the maintenance also is quite expensive. So on the sea it's much more expensive than on land. Photovoltaic, the prices came down a lot. Still they are a bit higher than the electricity generated in fossil fuel fired power plants. And and here we have electricity from biogas. Okay.
Maybe you can tell us more. What is the meaning of the bandbreite?
Well, this is just it depends. Take for instance the wind energy onshore. So you have better locations and you have weaker locations. So in Germany, for instance, in northern Germany you have much more wind than in southern Germany. So the electricity is cheaper you generate in northern Germany than in southern Germany. It depends also a bit on the infrastructure conditions, whether there is a highway besides or not. So it's just the costs that, the normal costs, they vary here between these two values. The same happens in the other technologies. Okay, so what have we learned until now? We have learned that some technologies, especially wind turbines and photovoltaics, are now, they are cheap compared to before. And in the case of wind energy, the capacities have grown a lot. So the conditions are given now to apply these technologies on a large scale. They really can contribute substantially to the energy supply of our countries. This was different 30 years ago, where they were used as for niche applications, but not for the big market. This has changed completely over the last years. That means that we now have completely new conditions to realize the Energiewende. We have completely new conditions to transform our energy supply system to a system which is based on renewable energies. This is the development of the electricity share generated from renewable resources in Germany. So you can see here the total electricity, electric energy that was generated over the last years. And here you can see the renewable energies that started to grow, especially from the 1990s on. And yeah, you have the, here on in the lowest line, you have the water power, hydropower, then wind power, biomass, the green one, and photovoltaics. So, and here this is the same, just another scale. Okay. Yeah. Now the question is, how will future energy systems look like? This is a very general question. Maybe it's too general to answer this question in such a short talk. We can break down this question to several sub-questions. For instance, where does the energy come from, which we will use? Does it come from the sun, from the wind, from biomass, from rivers, from the ocean? Another question would be, which types of end energy do we use? What will be the role of electricity? What will be the role of chemical energy? Which technologies do we apply? Or how do our grids look like? What kind of grids will we have to distribute the energy? All these questions are very complex questions, and I will pick out just one. And the question I will pick out is, where does the energy come from in the future? Anyway, thinking about this question in an indirect way leads also to the other questions. Still, this question is very general, and especially this question will be answered in different ways for different countries. We cannot expect that all countries in the future will have the same type of energy supply systems. It depends on the natural conditions in those countries. Nevertheless, I think we can say some general things. We can give some general answer to this question. What we can do first is we can ask, what energy flows do we have on Earth? Because the energy flows we have on Earth are the basis for our energy supply systems. So let's have a look at this. Energy flows on the Earth. The most important energy flow we have on Earth is the solar radiation. Yeah, now we have some very ugly big numbers here. 5,500,000 exajoule. What is exa? Exa is 10 to the power of 18. So yeah, this is on a global scale. We receive 5,500,000 exajoule per year in energy terms, or if you want to have it in power terms, this is 175,000 terawatt. Tera is 10 to the power of 12. Such big numbers are always a bit ugly, and is this much or not much? Well, we don't know. Yeah, we know it is much. Just compare it to the global primary energy consumption. This is 550 exajoule per year, or around 18 terawatt. So you have a difference of 4 orders of magnitude in between, factor of 10,000. Energy students, remember this number. 10,000 times more solar energy than our primary energy consumption. It's a good number to remember. Okay, yeah, and this is the global electricity consumption, so it's about 70 exajoule per year, 2.5 terawatt. Solar radiation, this number we know very exactly. Now, wind, this is difficult to calculate, to know how much wind energy we have available in the atmosphere. There are different calculations. You can look for them in the literature. You will find different numbers. The order of magnitude is always like this here. The number changes a bit, but yeah, something around 30,000 exajoule per year, 1,000 terawatt. It's also quite a lot. Biomass generation is an order of magnitude less, 2,500 exajoule per year, 83 terawatt. A geothermal heat flow is even lower, 1,000 exajoule per year, or 33 terawatt. Ocean energy, only counting the mechanical energy, waves, currents, tides, 300 exajoule per year, or 10 terawatt. And hydropower, that means the potential energy of the water in the rivers. The water at the beginning in the river is higher than afterwards. This is about 200 exajoule per year, 7 terawatt. What do we learn from this? Maybe not so much, but we learn at least that solar radiation is an enormous resource. Wind also, and then it's becoming less. Nevertheless, the other sources are very important too. Okay, maybe we learn one point more. What's the type of energy we generate from these sources? From solar radiation? Well, we have the typical technologies to use solar radiation are PV and concentrating solar power plants and solar thermal systems. So here we generate electricity or heat. Wind, normally electricity. Maybe in some applications mechanical power also. Biomass, well, in the first instance, chemical energy. Geothermal heat flow, yeah, electricity or just thermal energy. Ocean energy is mechanical energy, electricity. Hydropower, electricity. Most of these sources deliver electrical energy. This gives a hint that possibly in the future, and actually many people expect this, electrical energy will be even more important in the energy system than it is now. Yeah? Nowadays, our energy supply system relies basically on chemical energy. For instance, in Germany, the end energy, if we have a look at the end energy, 25% of the end energy is electrical energy. 73% is chemical energy. The rest is thermal energy. In the mobility sector, 3% electrical energy, 97% chemical energy. Heat sector, 10% electricity, and the rest chemical energy. So at the moment, our systems are based on chemical energy, basically. This may change in the future. I will come back to this topic later. Okay, now, which energy sources among these sources we have seen will be used? This is basically a cost optimization problem under, as I call it, under politically defined frame conditions. What do I mean with this? Okay, cost optimization, of course, we need an energy supply system which generates usable energy at affordable prices. This is essential because we are not doing science when we are building an energy supply system, but we want to sell the electricity to people, and this must be economic. And yeah, under politically defined frame conditions, I will say about this right now. First, we have to ask what is the availability of the different resources or the potential in a given area. For instance, we can ask this for Germany, we can ask this for Indonesia. What is the potential of solar energy for Indonesia? What is the potential of solar energy for Germany? The concept of the potential is a difficult concept.